Hi dears, welcome to today's class. Today we are going to learn a very interesting and important topic in mathematics, that is the area of a circle. So let's begin our class and study how to find the area of a circle in a very easy and simple way. Let's move on to today's class. Alright students, look at this slide. Can you identify what these objects are? We have the wheel of a vehicle, a coin, a ring, a plate, a wall clock and many more items that we use every single day. Now, let me ask you a question. What is common in all these objects? Yes, you are right. All of them are circular in shape. These are examples of daily life objects where we see circles around us. And for many of these objects, we often need to know how much surface they cover. To find that, we use the concept called the area of a circle, which we are going to learn today. Now, before we start learning the area of a circle, let's quickly recall something we already know. Look at this slide. First, what is a circle? A circle is a closed curved shape with which all points are at the same distance from a fixed point called the center. So remember, the center is the middle point. Now, what is a radius? The radius is the distance from the center of the circle to any point on the circle. Now, let's recall two more important terms, diameter and circumference. The diameter is a straight line passing through the center of the circle, joining 2 points on the circle. It is twice the radius. So we can say diameter is equal to 2 into radius. Next is the circumference. Circumference simply means the boundary or the outline of the circle. It is the distance all around the circle, that is, the perimeter of a circle is called its circumference. We know the equation for circumference. Circumference is equal to 2 pi r. We already know the value of pi, that is pi is equal to 3.1428 etc. These four ideas, circle, radius, diameter and circumference, are very important because they help us understand today's topic more clearly. Now students, look at this circle shown on the slide. Here, the point marked O is the center of the circle. From this center, if we draw a line to the boundary of the circle, we get the radius. So, any line from point O to the circle's edge is a radius. Now look at the line segment AB. It passes through the center O and touches both sides of the circle. So, AB is the diameter of the circle. Remember, O is the center, OB or OA is the radius of the circle and AB is the diameter of the circle. And as we recalled earlier, diameter is equal to 2 into radius. Alright students, now let me ask you a simple question. What do you mean by area? Area means the surface covered by an object. It is measured in square units. Area is a word we use very often in mathematics. In short, area is the surface covered by any object or any shape. If we shade the inside region of a shape, the shaded part is called its area. Also remember, the area of any shape is always measured in square units such as square centimeters, square meters and so on. So, once again, area means the space or surface covered by a shape and it is measured in square units. Now students, here we are talking specifically about the area of a circle. So, what is the area of a circle? The area of a circle is the amount of space enclosed within its boundary. In other words, the whole region inside the curved line of the circle is its area. If you imagine coloring the inside of the circle completely, the entire colored part represents the area of the circle. Now, look at the 4 circles on the screen. In the first circle, you can see a triangle drawn inside it. In the second circle, there is a square. In the third one, we have a regular pentagon. And in the fourth circle, a regular hexagon. As we move from triangle to the hexagon, what do you notice? Yes, each time we increase the number of sides, the polygon starts fitting the circle better. Don't you think so? So, as the number of sides increases, the polygon becomes closer and closer to the shape of a circle. This idea helps us understand how the area of a circle is derived. Now, you can see a regular pentagon drawn inside the circle. I have drawn lines from the center of the circle to each vertex of the pentagon. By doing this, the pentagon is divided into 5 congruent triangles. We already know that the area of one triangle is given by half into base into h, that is half bh. Here, the base of each triangle is the side of the pentagon, which we call S, and the height is the perpendicular distance from the center to the base, which we call h. So, the area of one triangle is half into S into h. Otherwise, we can say that area of a pentagon is equal to 5 into half bh, since here are 5 triangles. So, here the base is equal to side of pentagon, that is S. Therefore, we can say that area of a pentagon is equal to 5 into S into H into 1 by 2. Here, we know that 5 into S is equal to the perimeter of the pentagon. Therefore, area of pentagon is equal to P into half H is equal to P by 2H. That means the area of any regular polygon is half into perimeter into height. Now, we are using the idea we just learned. We know that as the number of sides of a regular polygon increases, its perimeter comes closer and closer to the perimeter, that is the circumference of the circle. In the previous slide, we saw that the area of a regular polygon can be written as half into perimeter into height. So, for a circle, when the number of sides becomes extremely large, the perimeter of the polygon becomes the circumference of the circle and the height becomes the radius. So, area is equal to 2 pi r, that is the circumference of the circle divided by 2 into r. Otherwise, area is equal to half into circumference into radius. And we know circumference is 2 pi r, so we substitute area is equal to half into 2 pi r into r. The 2 and half cancel each other, so we get area of a circle is equal to pi r square. Therefore, we conclude that the area of a circle is pi r square. Is it clear, students? Now, let's try a simple question to apply what we learned. The question is, find the area of a circle of radius 4 cm. Here, the radius r is given as 4 cm. We know the formula for the area of a circle. Area is equal to half is equal to pi r square. So we substitute the value. Area is equal to pi into 4 square. That is, area is equal to pi into 16. So the area of the circle is 16 pi square centimeters. Now, let's consolidate today's class. In today's class, we learned about the area of a circle. We can say that the area of a circle is the space enclosed within its boundary. Also, we found out the formula to find the area of a circle. That is, area of a circle is equal to pi r square. Now, here is a follow-up activity for you. Find the area of a circle of diameter 7 cm. So, that's our class. Today, we explored a very important concept in geometry, that is the area of a circle. We began by identifying circular objects from daily life, recalled the idea of radius, diameter and circumference, and then understood how the formula for area is actually derived using regular polygons. Step by step, we saw how increasing the number of sides of a polygon makes it look more and more like a circle. Using that idea, we finally arrived at the beautiful formula area of a circle is equal to pi r square. We also solved a problem to understand how to apply the formula. I hope this lesson helped you see not just the formula but the reason behind it. Keep practicing similar problems so the concept becomes clear and strong. Thank you for watching and see you in the next class.